Aloha champions! Today is Wednesday, April 29th, 2020. Today we are looking at chapter 6.3, Real World Problems Involving Area and Perimeter. Our learning objective for today is that we are going to solve real world problems involving area and perimeter of composite figures. These can be found in your math workbooks. I'm on page 141 to start, and I'll tell you what page I'm working on so you can follow along. First question we have is our engage question here on 141. It says, Sarah's garden measures 12 yards by 9 yards. The garden has a rectangular flower bed in the middle of it. The flower bed is surrounded by a stone path that is 1 yard wide on all sides. What we need to do is we need to find the length and width of the flower bed and use them to find the area of the flower bed. So area is the key word we're looking for here in this word problem. Area tells me that I will need to use my formula of length times width. Now for this problem, it gives me the length and the width of the total garden, but not the flower bed. So before I can find my area, I will need to subtract the 1 yard, 1 yard, 1 yard, 1 yard from that. So because it's 1 yard in and 1 yard out, for both my length and my width, I just subtract 2 yards. I add this yard plus this yard for 2 yards. So if I subtract 9 minus 2, that gives me a width of 7 yards. And then if I subtract 12 minus 2, that gives me a length of 10 yards. Now that I've subtracted this down, I know that this is 10 yards and this is 7 yards. If I multiply my length times my width, that will give me my area. So 10 times 7 equals 70. Because this is a word problem, I want to write my answer as a full, complete sentence. The area of the flower bed is 70 yards square. Anytime we find an area, we put that little 2 behind to say that it is squared. So the area of the flower bed in our first problem is 70 square yards. Now I'm going to skip 2 pages till I'm on page 144. This says try to practice solving real-world problems involving area and perimeter of composite figures. I'll read the problem. If you would like to pause the video to try it on your own and come back to see what I've come up with on my end, you are more than welcome to do so to get you practice in this. So, the figure shows a rectangular field with a path 2 meters wide around it. We need to find the area of the path. We need to find the area of the white path around the field, okay? It does give us hints here of what we need to look for. We need to find the length of the large rectangle, the width of the large rectangle, the area of the total rectangle, the area of the field, or the small rectangle, and the area of the path, which will be the area of the large rectangle minus the area of the small rectangle. This has our sentence starter down at the bottom. The area of the path is blank square meters. And that will be our answer for this problem. So if you want to take a moment to pause the video and try to work through this problem, you can. All right, bringing it back in. So we're trying to find the area of the white here, and we're given some lengths. We know that the field is 25 meters with a 2-meter path on either side. So if I add 25 plus 2 plus 2, that will give me the total length here. So 25 plus 2 is 27. 27 plus 2 is 29. The total meters here is 29 meters. Next, I need to do the same thing for the width with a 12-meter width plus 2 and 2. So 12 plus 2 plus 2. Okay? 12 plus 2 is 14. 14 plus 2 is 16. So the total width is 16 meters. Now, it says find the area of the rectangle. They're referring to the whole rectangle around the path around the field to find all the area. So that's using my formula of length times width. And I'm going to be multiplying 29 times 16. Over here in my blank area here, I'll line up my multiplication problem. 29 times 16. I start 1 times 1, 6 times 9. That gives me 54. I put my 4 in my 1 spot, carry a 5 into my 10 spot. Now I do 1 times 10, which is 6 times 2, which would give me 12 tenths. 12 tens plus 5 tens is 17 tens. Now I'm on to my tens. I put a 0 in my placeholder because 10 times 9 would give me nothing in my 1 spot. Now I just multiply 10 times 9. That gives me 90. 10 times 20, which gives me 200. Add these all up. 4 plus 0 is 4. 70 plus 90 is 160. 100 plus 100 is 200. 200 plus 200 is 400. So the area of the rectangle that is 29 times 16 is 464 square meters. Now the area of the small rectangle, or the field, is going to be my smaller length and width, my 25 meters times 12 meters. 25 times 12. Where I have open space, I'm going to lay out my multiplication problem to find the area of the smaller rectangle. 25 times 12. We have 2 times 5, it's 10. 2 times 20 is 40, plus 10 is 50. Now I'm in my 10 times my top number, put a placeholder 0. 10 times 5 is 50. 10 times 20 is 200. Add those all up, I have a total of 300. So now I know the area of my total rectangle, the area of my field. If I subtract my total minus my field, that will give me the total area of just the path around. So plug in my numbers. If I have 464 minus 300, that would give me the area of the path is 164 square meters. Now for this practice problem, it does give me the sentence starter here, so I can just plug that in. When it comes to the assignment page, the page you are responsible for, it is your responsibility as a scholar to remember to put your answer in a full, complete sentence. Okay? Moving on now to page 145, we have another try that gives us some guidance of how to do this. I'll read the problem. I'll give you an opportunity to pause the video and try this on your own. This is page 145. Problem number 2. The figure shows a small rectangle cut out from a larger rectangle, ADEF. We need to find the area of the shaded part of the figure. So they've taken out BHGC And now we need to find the area of the total yellow space here. To do so, it's asking us A, to find the length of the large rectangle, B, find the width of the large rectangle, find the area of the large rectangle, find the area of the small rectangle, and the area of the shaded part, which would be the large rectangle minus the small rectangle, which will give us the total shaded part. So instead of the shaded part or the empty part being around it, it's a part of this, but we can still figure this out via multiplication and subtraction. Multiply to find your area, subtract the two areas you have to find your total. Okay, pause the video, work through the problem. All right, now I'm going to work through this. First, I want the length, so the length from F to E or A to D. Well, A to D has these three lengths here. We have a 2 yard, a 4 yard, and a 2 yard. So just like I did in the last one, add up all of those together. 2 plus 4 is 6, 6 plus 2 is 8. The width of the large rectangle is 6 yards because we have D to E, 6 yards, it's uninterrupted, no need to add. Now I'm going to find the area of the whole rectangle before that piece was cut out from it. So I'm going to multiply this length times this width, 8 times 6. 8 times 6 is 48, or 48 square yards. Now I need to find the area of this small rectangle. The small rectangle has a length of 4 yards and a width of 3 yards. Found here on the side of A to F, runs parallel to B and H, C and G, so it's 3 yards here. 4 times 3 is 12 yards. So altogether, it's 48 yards, and they took away 12 yards. So to find the area of the shaded part that's left, I'm going to have 48 minus 12. 48 minus 12 is 36 square yards. Down here, I have a full complete sentence. I just plug in my answer of 36. And the answer reads, the area of the shaded part of the figure is 36 square yards. So when you're doing the assignment pages, please remember to write your answer as a full, complete sentence. On to part 2. This is now page 147. I know there's a problem up here. We're going to skip over that problem. I'm going into the Learn section here. So, to find the area and the perimeter of parts of a figure, we have this sheet of paper with a corner that's been folded in. To find the area of the shaded part is a triangle, and that triangle is a perfect half of a square. So to figure out the area of that triangle, if I do length times width divided by 2, that will give me the total area of that shaded triangle. So if it was a full square before we cut it in half, it would be 2 times 2, which equals 4. Then I divide 4 divided by 2, which gives me 2. So the area of the shaded part is 2 square inches. To find the perimeter of the square piece of paper unfolded, if I unfold this, it will give me a length of 2 and a length of 5. It's saying that it is a square, so all 4 sides are equal. So my bottom, or my length here, would be 5 plus 2, which gives me 7 inches. And to find the perimeter, remember I'm tracing around the outside of the shape. How long would it take me to go all the way around that? Well, it's 4 sides of 7, so 4 times 7 would give me 28 inches. The perimeter of this square piece of paper would be 28 inches. Double check your questions, see if it's asking for area where you multiply, or if it's asking for perimeter where you add. We're gonna do a few practice problems where we have some triangles here, or just one practice problem before I tell you what your assignment for today is. This practice problem is on page 149. I'll read the problem, then you can pause the video to try to work through it, and then unpause to see Mr. Chambers work through it. So, a rectangular piece of paper is folded at one of its corners so that the side BC lies along the side CD as shown. So BC folds in, so we've got this square with a triangle, and first we need to A, find the area of the rectangular piece of paper before, so this one, the before picture, you want the area, so length times width, before it was folded, and then you want to find the area after. So looking at those key words. So I'm going to give you a moment to try this on your own. You may pause the video to work through this problem. All right. So for this problem, I'm only finding the area of the piece before and the piece after. So the piece before is just a rectangle with a length of 8 and a width of 4. To find my area, I multiply my length times my width to have 8 times 4. 8 times 4 is 32. So the area of the paper before was 32 square inches. Write my answer out as a full complete sentence. For problem B, after it's folded, after we take corner B and fold it in, what is our area now? So to find this area, we know that the total was 32. Now it's been split into half here. So if I take 32 and split it in half, 2 goes into 3 one time, minus 20 gives me 12. 2 can go into 12 6 times. So the area of this square is 16 inches. The triangle is also part of the paper that we can see, and that will be half of our 32 split into half. So this will be 16 divided by 2. So 16 divided by 2, 2 can go into 16 8 times. So now I add up this square and this triangle, so I have 16 plus 8. And that will give me the total area after the paper was folded. So 8 plus 6 is 14. 10 plus 10 is 20. Now I need to write this as a complete sentence. The area of the paper after, was 24 square inches. So we lost 8 square inches by taking off this part here. So that will wrap it up for today's lesson of this, your assignment pages found in your math workbook are pages 151, 152, 153, and 154. It's 4 questions with 1 or 2 parts each, and you're either finding the area by multiplying or the perimeter by adding. So thank you for tuning in for this lesson. There is a Crazy Alice coming out tomorrow in which you will be using area and perimeter for a fun project. Thank you, and I'll talk to you soon. Bye.